In this second example of a pedigree chart, we have a slightly different view as to the one that we had before. It looks similar, but instead of having names of grandmother, grandfather, for example, we have circles and squares to represent people in the family tree in the pedigree chart. So it states in the question, the diagram represents the family tree and the inheritance of the ability to tongue roll. So tongue rolling is dominant, so capital R for rolling, to non-rolling, which is small r. Okay, so in this example then, we have capital R as a roller, we have small r as a non-roller. So this cross in this pedigree chart shows each of the stages in a cross that we're used to. So this would be your P generation, this again would be your F1, and this would be your F2. So in terms of possible genotypes that we've talked about before, if you had a roller, so a roller you could either be capital R, so homozygous dominant, or you could be capital R, small r, so heterozygous. If you're a non-roller, you would then be homozygous recessive. So you would have two small r's, lowercase r's. So just for clarity, capital R would be a roller, capital R, small r would be a roller, and then two small r's would be a non-roller. Now for the most part, it won't really matter whether it's a male or a female, unless the question asks you to name a male or a female in that family tree that has it, or asks you for a particular person. For the most part, it works just the same. So again, it's the same as the previous example. The only people that you know their genotypes for definite to begin with are the non-rollers, because they must have two small r's. So every person that's a non-roller, every person that's blacked box or blacked out circle, would then be two small r's. So this person would be two small r's. So would this, and so would this. Now every other person has a roller, and must have a capital R. So this must have a capital R. So must this, etc. Now to figure out the rest of the genotypes, what you have to do is work your way backwards. Okay, look from the children back up to the parent, or from the grandparent, for example, down. So if we're looking at this grandparent to begin with, all that they can ever give is a small r. Okay, they've given the small r to this child, and this child must have got the small r from this father. So therefore they must be big R, small r, must be heterozygous. The capital R must have come from this parent. Okay, same applies here. So we can have a look at it. We must have got one small r, one recessive allele from this parent. The other small r must have come from the other parent, so this must have come from over here. So that makes that grandmother heterozygous, makes them big R, small r. If you look at this child, okay, this affected female, this female non-roller, she has two small r's. One must have come from one parent over here. Therefore, the other one must have come from the other parent. So this parent must be heterozygous. Now looking at these two children, we need to then have a look at what their parents had and figure out whether they were homozygous dominant or heterozygous. So you can do another quick Punnett square to show this. And put one parent, for example this one, over here, and then the other parent on the side. So that means that any person that is a roller can either be capital R, small r, or two capital R's. We don't know which it is because we don't have any other parent or any other children to tell. Okay, they don't have children to be able to base that on. So either it could be this, or it could be that. Same for this one. Okay, now again, like we've done in the previous example, there might be another question. They ask, if the parents of the F2 generation had another child, what is the chance of the child to be a non-roller? So we take the parents' genotypes and we put them into our Punnett square. And we cross them. So the question is asking, what's the chance of them being a non-roller? So if we're looking at what we have, our genotypes that we have are 1 capital R, 2 with heterozygous, and 1 with 2 lowercase r's. So out of those 4 possibilities, okay, 4 people or 4 potential children, only one of them out of the 4 would be a non-roller. So 1 out of 4, or 25% chance.